In this video, we're going to begin using Excel in ways that are more than just as a calculator. So we are going to be using a lot of the different functions within Excel to calculate z-scores or areas to the left or right or between two z-scores, or to find the z-scores given the area. The first thing we want to talk about is how to find a z-score. And as I go through this video is going to be a little bit longer than the last couple of videos because I'm going to show you several ways to go about finding each of these solutions. And that's for your benefit. So what I'm trying to do is show you, here's how you would compute it one time. But if you have to do it 10 times or 20 times or 30 times, say as you're working through your certifications, you might choose to do it in a way that's going to save you some time. So I have already worked through all of the certifications, and this is the strategy that I used, the one on the right. So let's look at the one on the left first, and then I'll show you my strategy as I went through the certifications. The first thing is, of course, we have to understand how to find a z-score by hand. So to find a z-score by hand, remember it's observed minus expected over standard deviation, or x minus mu, where mu is the expected value, it is the mean of our population, divided by the standard deviation of our population, which is sigma. So if I just had to find the answer one time, like they're asking me in A, I would just use that formula, keeping in mind that Excel is going to use the order of operations, which means we have to tell Excel that this difference needs to happen before division. So I'm going to put equals, and then x is my observed 45 minus expected 48, close the parenthesis, divided by the standard deviation of 5. So I get negative 0.6 as my result, and that is the correct answer. Now, before I do question B, I want to show you what I've done over here. I have found this formula, and I've created these 4 input boxes to help me to find Z or to find a missing value in case I'm lazy and don't want to have to redo it every time. So here's what I did. In this box, I have entered E8 minus E9 divided by E10. So E8 is x, E9 is mu, and I'm taking the difference of that divided by sigma. So again, why did I do that? Because now I can say, okay, if this is 45, and this is 48, and this is 5, notice all I had to do is input the values and Excel did all of the work for me because I was smart enough to come up with that formula. So again, what if I have to do a question like B? So first let's talk about how we would find B. If I have that Z is equal to x minus mu divided by sigma, and I need to find sigma, then I'm going to first take each side times sigma because I don't like sigma to be a denominator. So now I have sigma times Z is equal to x minus mu. Now I'm trying to get sigma by itself, so now I'm going to divide by Z on each side. So that gives me sigma is equal to x minus mu divided by Z. Now notice I now have sigma by itself. So I can answer this question by doing the exact same thing I did before. I'm going to put equals and then parenthesis, and then x is 45 minus mu is 42, close the parenthesis, divided by Z, which is 0.5. And I get positive 6, and that's the correct response. Now again, what have I done over here? Well, I did all of the algebra for you, and I isolated each variable. And then I entered those formulas in. So all I have to do is remember to clear out my input boxes, and then to find question B, I would calculate the value given x is 45, mu is 42, and Z is 0.5. And then again, voila, I've come up with the right answer. And I could find any of those missing values now just using those input boxes. So again, that's just one strategy to use that I encourage you to use. I promise you it will make your certifications go much, much more quickly. Let's take a look now at a couple of questions where we're asked to find the area under the curve to the left or the right of a value. So before we do that, I just want to make sure we're clear on exactly what's happening. So hopefully you got this from your certifications this week. But when I have a normal model, the mean of that normal model, in this case 98.6 degrees Fahrenheit, goes right in the middle. The standard deviation is sort of the ruler for how far away we can expect values to be. So for my first question, it says the probability of a healthy adult having a body temperature less than 97. So 97 is going to be somewhere to the left of 98.6. And then because it says less than, I would be looking at something like this. So when I say left or right, I'm saying this is to the left of 98.6. And that is what I'm trying to figure out, is that area. So if I were asked to find that area and to find the z-score, which quite often you will have to find both. So if I have to find the z-score first, let's do that because we already know how to do that. We just reviewed it. To the left, the z-score would be observed, which is 97, minus expected, which is 98.6, close the parenthesis, divided by the standard deviation of 0.73. So my z-score is negative, which makes perfect sense because any z-score to the left of 98.6 is negative. To find the area to the left of that, I'm going to put equals, and then the formula or function that we use is norm.dist. And norm.dist, again, notice it's popping up with everything I need. X is the z-score, comma, and whenever I'm using a z-score, the mean is 0, the standard deviation is 1. That's what a z-score does. True is always going to be chosen because true tells me that yes, I want cumulative. I want to take that value, everything to the left of that. So then I close the parenthesis. So that's a correct response. Now let's say they asked that question, but they did not specify that I had to find a z-score. Well, then we're off the hook. We don't need to do this z-score part. I can go straight to norm.dist, just as I did before. And instead of x being my z-score, x is going to be that 97. So 97, now instead of mean of 0, standard deviation of 1, I have to use 98.6 and standard deviation of 0.73, but I'm still using true for cumulative. Notice I get the exact same response, and it was easier because I didn't have to first find the z-score. Now, for the second question, and then we'll get to that part on the right. So if you're doing this for, say, your project, you're probably going to do it the way that I'm doing it right now on the left. Again, second question, what's the probability of a healthy adult having a body temperature more than 99.2? So again, if this one asks for a z-score, I'm going to put equals, and then the observed value is 99.2 minus expected 98.6, close the parenthesis, divided by the standard deviation. So my z-score is 0.82, and then the area to the right, just as we did before with cumulative always being to the left in, say, the hypergeometric or binomial distribution, it's the same for the normal distribution. So if I want to find the area to the right, I'm going to put 1 minus the area to the left because the total area is 1, so it's just going to give me the complement. So the area to the right would be, and again, it's to the right because we're looking at more than 99.2. So it's to the right-hand side of 99.2. So I'm still going to use norm.dist. This time my z-score is this positive value with a mean of 0, standard deviation of 1, and still cumulative. Or, to make it easier, if I don't have to find the z-score, it's still 1 minus, and it's still norm.dist, but now x is going to be 99.2, the mean is 98.6, and the standard deviation is 0.73, but it's still cumulative. Notice I've gotten the same value each time, no matter whether I use the z-score or not. Now, if I were to do this on my certifications, I don't want to have to be typing in everything every single time. So this is the strategy that I used, and I encourage you to use it as well. It's not cheating, it's just being really smart about your resources. So what I have done is created an input for x, which is my observed value, mu, which is my mean, and sigma, which is my standard deviation. I've then created a formula for the z-score in case I need the z-score. And then I've also given the area to the left using the z-score and not using the z-score. And then area to the right using the z-score and not using the z-score. So feel free to enter those values in. And again, I would just put x. So if I was doing question A, 97 would be x. This would be 98.6. This would be 0.73. And notice the z-score is the same as the z-score, and the area to the left is the same as the area to the left. This one, again, using the z-score, comma 0, comma 1. This one using these values. And then if I needed to do question B, I would just change 97 to 99.2, and then voila, new z-score, which matches, area to the right, which matches. Let's take a look at a few more difficult questions now. And again, it's important for us to understand exactly what we're trying to find so that we can tell Excel which direction to go or what to add or what to subtract. So we need to be smarter than Excel so that we can tell Excel what to do. So for our first question, we're going to look at the area between two values. So again, if I'm thinking about that normal model, and right here in the middle is 98.6, which is my mean. And my first question says, what's the probability of a healthy adult having a body temperature between 98 and 99? So what I'm really looking for is, if say this is 98 and this is 99, and again, it doesn't matter if you suck at drawing like I do, I'm looking for this value, which seems easy enough, but if you'll recall, Excel will only find the area to the left of a value. So if I said, let's do norm dist using 99, that's going to give me all of this. And if I said, let's do norm dist of, say, 98, that's going to give me to the left of 98. But I want just this value in the middle. So essentially what I'm saying is, if I take all of this, which is the 99, and then I subtract all of this, which is the 98, notice what area is left over. If I take away this, I'm taking all of this away. What's left? Just the part that I care about. So essentially what I'm saying is, if I want the area between two values, I need to take the greater, again using norm dist, minus the smaller or lesser using norm dist. So let's work through this first one together. If I start by finding the area to the left of 99, and I'm going to skip over the z-score completely. If I just need to find the area to the left of 99, that's norm dist, and then 99, and then my mean is 98.6, my standard deviation is 0.73, and cumulative, yes. Now, if I just ended it right there, that's everything to the left of 99. Now remember, I need to take away everything to the left of 98, so I'm only left with this part between 98 and 99. So I'm going to go back up here, and then I'm just going to subtract, and then I'm going to use norm dist again. Now, again, I'm just finding area to the left, so I don't have to worry about 1 minus anything. So norm dist, and then this is 98, comma, 98.6, comma, I don't remember it, 0.73 comma 1. So that's the area between the two values. And again, I'll get to this part in a minute, but that's the correct solution. Now, if I want the area to the outside, so let me get rid of all of my beautiful drawings here. If instead I want the area to the outside, then I need to think about adding two different values. So the probability of less than 97.6, so here in the middle is 98.6. 97.6 is here, and I want less than that. And then 100.6 is over here, and I want more than 100.6. So we know already how to find this one. This is just the regular norm dist function, because that finds the area to the left. So I'm going to find the left of 97.6. And then 100.6, remember, if I'm finding the area to the right, that's 1 minus norm dist. And then on this one, I just have to add the two together. So I'm going to take equals. The first one is norm dist. Actually, I'm going to always start with a higher one, and I'll show you why in a minute. So to find the area on the right side, to the right of 100.6, it's 1 minus norm dist, 100.6, comma 98.6, comma 0.73, comma 1, close the parenthesis again, and then I'm adding to that the area to the left of 97.6. So that's just norm dist, 97.6, comma 98.6, comma 0.73, comma 1. Close the parenthesis, and we're done. So that's the correct solution. But now let's take a look at how I could do this easier, right? So if I wanted to do this easier, I'm sorry, I'm a little OCD, I need them both to be centered. If I want to do this easier, notice I've already created a z-score formula, and for x1, this is going to be the bigger one. And it's better to know which one's bigger and which one's smaller. So if I'm doing question A, notice I've already set up a z-score formula for the bigger, for the smaller, and then I'm using the exact same functions that we just talked about. For between, I'm just subtracting the bigger minus the smaller, and this one's using the z-scores, or bigger minus smaller, not using the z-scores. And then for outside, again, it's 1 minus for the bigger, and then just regular for the smaller, using z-scores or without z-scores. So if you take the time to set up everything, it makes these really easy. So watch, I can do question A. 99 is the bigger, and 98 is the smaller, and I just got the same answer. And then if I'm doing B, the bigger is 100.6, and the smaller is 97.6. And again, this answer matches this answer. So if you take the time to set up these cells correctly, then this makes these questions much easier to deal with instead of having to recreate the wheel every time. So in my announcements, when I say now's a good time to start creating a spreadsheet, create a spreadsheet that talks about here's how we did it in chapter 6, and then next chapter, in chapter 7, you're going to learn some more things, and you might make some more tabs. Just keep adding tabs to the bottom and make it easier on yourself. Let's take a look now at how to find a z-score or a value given the area. So we've been working on finding the probability or the area given values in the question or given a z-score. Now we're going to do the opposite, so we're going in reverse. And the good news is the only thing we have to remember is instead of norm dist, it's a norm inverse function. So for instance, for A, the area to the left of 0.239, I'm going to put equals norm inverse, INV. And the probability is 0.239 the mean is 0 and the standard deviation is 1. So using the mean of 0 and the standard deviation of 1, it's going to return a z-score. Now, doing the exact same question, but instead of finding a z-score, I'm finding the value in the question. So for instance, the normal model with a mean of 52 and a standard deviation of 3, what would be the raw score? So we know it's going to be a little bit less than 52 because obviously this is a negative z-score, but really the only thing I have to do is norm inverse. I'm still putting 0.239, but now I'm putting the mean of 52 and the standard deviation of 3, and notice now it gives me the score instead of the z-score. So this is the z-score, and this is the score in relationship to the mean of 52 and the standard deviation of 3. For B, the 80th percentile means there are 80% below it. So all we have to do is think about 80th percentile as a decimal. So instead of 80%, it's 0.8. So I'm going to do the exact same thing. Norm inverse, and probability is 0.8. So remember, probability is always between 0 and 1. And then the mean of 0 and the standard deviation of 1. And then I'm going to do the same thing on the right. And instead of using 0, 1, I'm going to use the mean of 52 and the standard deviation of 3. Now, of course, there is a mathier way to take this z-score and to turn it into this raw score, but it's not necessary for us to do that. The last one says the area to the right of 0.963. Now keep in mind, norm inverse only deals with area to the left. So the easiest way around that is to do norm inverse, and instead of 0.963, just put 1 minus 0.963. Let Excel find that value for you. Mean of 0, standard deviation of 1. Or, same thing, norm inverse. 1 minus 0.963, again because it's to the right instead of the left, and then the mean of 52 and the standard deviation of 3. The last examples are a little bit trickier only because you really have to understand the normal model. Now keep in mind we have our normal curve, and when you have z-scores on it, you have a 0 in the middle, and then for instance, for question A, we're saying there's some value over here, and there's some value over here, where the area between the two values is 90%. So the first thing we need to understand is these two values are the same. One is positive, one is negative. The other thing we need to understand is if I take 100% and I subtract the 90%, that gives me 10%. If I divide that by 2, I get 5%, and that means there's 5% here, and there's 5% here. So again, 5 plus 90 plus 5 is 100, so it all adds up to 100. Now, why is that important? Because for the first question, where I'm not finding the values but the z-scores, I need to find the area between z and negative z. So on my line here, the area to the left of negative z, and left is important, is 0.05. The area to the left of positive z is the 5% and the 90%, so area to the left of this is 0.95. So I want you to see what happens when I say equal norm inverse, and then I use 0.05, 0, 1, and then I do the same, norm dot inverse, and then 0.95, 0, 1. I get the exact same value, 1 negative, 1 positive, which makes perfect sense because this value would be negative 1.6449 and this would be positive 1.6449. I can do the same thing for using the actual values. So in this one, I could have just found the negative value and then said, okay, and then it's the opposite. But I can't do that here. So what I'm going to do is I'm actually going to see if I can just copy both of these. And now instead of 0 and 1, I'm going to replace 0 with 52, and I'm going to replace 1 with 3. And I'm going to replace 0 with 52, and I'm going to replace 1 with 3. And so, based on the fact that, again, I could redraw this model with 52 in the middle, that's telling me this guy is 47.065, and this guy is 56.935. So again, I did the exact same thing using norm inverse, but just changed the mean and standard deviation. Using that same idea, the area in the tail is 20%. So again, I'm just going to take this over and re-put different numbers on there. So if the area in the tails is 20%, that means there's 10% in this tail, and there's 10% in this tail, and there's 80% in the middle. So now if I'm trying to find my two values, I'm going to use norm inverse for 10% to the left, 0, 1. And then how much is to the left of my other value? Well, 10 plus 80, which is 90. So equals norm inverse, and then 0.9, 0, 1. So that means these two z-scores would be negative 1.2816 and positive 1.2816. And again, if I just copied and pasted and then changed 0 to 52 and 1 to 3, and I did that twice, 0 to 52 and 1 to 3, then that would give me the raw scores, 48.155 and 55.845.